Good morning, everyone. Welcome to the first session of the 2023 GSE UK CICS Working Group sessions. Some of these sessions, well, in fact, most of them are repeats of the live sessions we had in November at Whittleby Park in Northampton. So if you've been to any of those, watch out because you'll get a duplicate. If you need reminding, that's great. I know I do. And today we've got the esteemed John Tilling from Hursley, who's come to talk to us about CICS 6.1 and in particular all the many foundation changes that we've requested or been given to us by IBM. So without further ado, I know it's a packed agenda, John, in the hour. So if you could take it away. Thank you very much.
Okay, thank you, Rob. Well, good morning, all.
Oh, sorry. It's typically me disorganised. Yep. If anyone's got any questions, you're all on mute. We'll have a question session at the end if there's time, but you can put any questions, any burning questions in the chat, and we'll try to monitor that and bring those up for John on your behalf. So, sorry, John, carry on, please.
Okay, well, good morning, all. My name is John Tilling. I'm CICS Development Lead working in Hursley. I also head up what's called the foundation team, which is one of the sub-teams, if you like, of the development organization, concentrating on core foundation, hence the title. We're going to be looking at some of the core foundation enhancements we put in CICS TS 6.1, which went GA last June. So if I page past the usual disclaimers. So what are we going to be talking about this morning? So we've spent a lot of time on policy rules. So it can be lots of new policy rules, and there's some SPI, and then slightly connected to that, but not directly connected, is some new event capture points. I'll talk about those. We're going to be talking about managing TS capacity, some enhancements to shared data tables, a couple of CICS DB2 enhancements, a couple of small tweaks on HTTP and TLS, some small API and SPI, and finally some better management of CICS. We're going to be talking about some enhanced short-on storage capability. So that's the agenda this morning. You'll notice I'm not going to be talking anything about Java. There are separate sessions on that. And also there are separate sessions on security, because we've done a lot of work in 6.1 on security. So I won't be talking about that this morning. That's coming in a different session. So let's crack on and have a look at policy enhancements. So we've done a lot of work in version 5 on policy, and even more in 6.1, and quite a lot of that was prioritized by customers who were members of the CICS Design Partnership, who perhaps came to one of our face-to-face CAF meetings in, I think it was 2019, where we prioritized some of this stuff. But one of the big hitters, if you like, that at the time had probably the most votes in terms of RFEs. RFEs are now called ideas, as you're probably aware, but requests for enhancement was one concerning a much easier way of being able to scope down a policy task rule to a specific transaction perhaps, or a specific set of transactions, or to exclude a transaction or a set of transactions from a particular policy rule. You could do it, but it was a bit clunky. So we've come up with a much easier way of doing that, using what's called a context filter. We already had the context filters for system rules that apply to the CICS system as a whole, but not for task rules. So we've introduced that capability. The new filtering, as you'll see in the next couple of slides, is provided via enhancements to the policy editor that comes with CICS Explorer. And because this one was so popular in terms of requests, normally we would, in terms of CD enhancements, i.e. backporting, we would normally just go back one release. But for this particular one, we've gone back all the way to 5.4. So you can see on the screen there, it's available 5455 and 56 via that APAR, and you need CICS Explorer 55011 or higher. Basically, we're up to, they've changed the numbering scheme slightly on Explorer, they've dropped the 0, but we're up to 5527 is the latest and greatest, and it's always downward compatible. So as long as you have 11 or higher, then you will have the necessary changes in the policy editor to use this capability. So here's a screenshot of what it looks like in the policy editor. And here we've got the editor open, and we're looking at a task rule to do with asynchronous requests using the asynchronous API. And the new bit is the bit in the red box in the center there. You can see that it says limit this rule to a specific TRAN IDs and or user IDs. So you can do it for both TRAN ID and user IDs. And for example, in that red box, you can see that this policy is going to be restricted to a transaction ID called PG1 and the user ID HEJEN. So the actions or you can take, or sorry, the operators, you can see in that red box there, it's equals, but down the bottom here, you can see the options you have. You have equals, does not equal, starts with, or does not start with. So that's a way of, if you've got wildcarding, you can basically include a set of transaction IDs or exclude a set of transaction IDs, and it's simple as that. So a much easier way of scoping a policy rule to a set of TRAN IDs or user IDs. And if we move on to the next slide, the policy editor is intelligent enough to report the level of the rule that or the level of CICS you need to use the rule. So on the top there, because we have specified a transaction ID, so we've got a filter on here, it's saying that you require 5.4 or later, because on that previous slide I said it was available by 5.4 and up via that APAR. If you're not using the new filter, then down the bottom there it's saying this rule was available from 5.3. So the editor will report the level you can use it on depending on what functionality you are using. So that was the first one. There are a number of these. If we move on to the next, a policy task rule to control container storage. We had, again, this had quite a number of votes. So to be able to police a particular task, to protect against perhaps a road task that's gobbling up container storage. And you can typically, if you want to set a threshold here, you could look at the monitoring data, and we have an existing monitoring field, PGCS THWM, the container storage high watermark. So you can see from a normal run the high watermark you're using for tasks. So you might set a limit just above that. So of course it would protect against looping programs making large number of container requests. So this one we've put in 6.1, but we've also backported to 5.6 via the API. You can see at the bottom of the screen. And again, you need this time 55015 or higher of Explorer to pick up the policy editor change. So if you, in the policy editor, it gives you the list of task rules and system rules, and you can see there I'm just highlighting that second one down in the task rule category is container storage. Perform an action when the total amount of storage that is used by containers for a user task exceeds a threshold. And moving on again, you can see that you can specify the amount in either bytes, kilobytes, megabytes, or gigabytes, because this is actually going to monitor the amount of storage. It's actually 64-bit storage, because when your application is not accessing the data, it actually resides above the bar. So it's actually monitoring the amount of 64 bits storage that CICS is using to hold those containers on the channel. So what commands are tracked for container storage? Well, the obvious ones, put container or put 64 container. Delete container, of course, will reduce it, so that will be monitored. If a task is subject to an incoming DPL, for example, link program with a channel, which will pass in a set of containers, perhaps this is a long-running mirror task, then that will acquire, of course, the container storage, and so we'll monitor there. For started tasks, start trans ID with a channel, and for async API, run trans ID with the channel. So these task rules are not applicable to user tasks. They're not applicable to system tasks. So that is the set commands that we monitor in terms of keeping an eye on how much container storage is being used. Moving on again, the third policy enhancement. So this was specifying all requests for some policy task rules. Now, we had a number of existing policy task rules that applied to things like file control and temporary storage and transient data, where you could say, tell me if, or take an action if this program issues more than 10 read requests to a file or something like that. So it was quite granular in that you would choose the request. So in this example, this is the file policy. So you have the set of requests that you can select for your threshold. Well, this particular customer, he wanted to pick and choose. He said, well, I might want like 3 read requests and 4 read writes. And so he put in a request to be able to choose multiple items. Well, we took a look at this and thought, well, this is going to get very messy very quickly. So we went back to the customer and said, well, how about rather than you having an ad hoc combination, why don't we just give you an all option? So you can just say, you know, if any or whatever file control request this program is issued, I don't want to allow in more than 10, and they were happy with that, and that made the UI much easier. So that's what we've gone with. So we've added an all option to the following task rules, the one I've just shown you for file requests. It also applies to TS requests, TD requests, storage requests, and storage allocated requests in bytes, because those particular ones you can actually pick and choose what type of storage. So now you have the ability to say all types of storage, for example. So that was a pretty simple one to do. At the time, we weren't necessarily convinced how pervasive before we started these changes were going to be. So we took the decision that this one was just going to be in 6.1. We haven't backported it. So in here's just an example. You can see how it shows in the policy editor at the bottom. So you have the list of requests and you have the one at the bottom saying all file commands. And we're just showing the XML schema on the left there. And again, the policy editor is showing you that for this particular one, if you specify all, it requires 6.1 or later. So moving on again, this is an interesting one, a policy to control the total number of transaction dumps that a CICS region can take. Now, you're all no doubt well aware that we've had dump table capability for many years, if not decades. So you can have dump table options to control how many dumps are taken for a particular dump code, etc. But this was wanting something at the region level, and the reason the customer wanted this was unusually. This customer runs test and production on the same LPAR. They have to massively overcapacitize their system to cope with market open. So that's giving you a clue of the sort of people they are. So they have to cope with a massive spike in traffic at 9:30 for 2 minutes. and then things calm down. And for the rest of the day, until the sort of end of day processing, it might be, overcapacitized in terms of the system. So they soak up the spare capacity, if you like, by allowing test to run alongside production. That comes with some risks, if you like, and this particular customer wanted the ability to very quickly, if a test region was taking too many transaction dumps, they wanted to shut it down. So they will be able to set a policy. We backported this to 5.6 via the API you can see there, and Explorer 5517 or higher. And so you can set a threshold for the total number of transaction dumps. I think what this particular customer would do was choose an action to drive an adapter, so which is effectively a piece of command level code you can write, and they'll probably go off and turn off all the dump codes for that particular region. So that gives them a way of doing that. So moving on again, another interesting one. This one's what we call a compound condition system rule. So the existing rules up to this point work on a single threshold, if you like, or a single action. And what we want here is an action to be triggered when multiple things are happen. So for example, you might want to take action when not only is the MQ connection connected to CICS, but also the DB2 connection is so you want to wait for two things to happen before you take an action. Another example could be, and this is the primary use case for the customer who raised this, they have a lot of applications that are installed via bundles. And as you're probably aware, installation of bundles is asynchronous. It goes on long after control is given to CICS, long after you get that message. And they wanted the ability to wait until they've got all their bundles in the right state. All their application bundles are enabled and ready in order to then open up work into the CICS region. And so the new compound condition rule will allow them to do that, but it's generic in nature. It's not just for bundles. You can, as I said earlier, you can use it for other things like MQ connections, DB2. And I'll show you over the slide, next slide, what conditions you can add into this compound condition rule. So you can see it's listed under system rules in the policy editor, compound condition. And on the right hand side, you can see the set of conditions that you can plug into this compound one. So you can have bundle available status, enabled status, DB2, MQ, DB control, files, etc. So that list there. So any number of those you can add into a compound condition rule. So if we move on again and give you an example. So here on this screen in the red box, you can see that I've got an example here with, it's got two conditions, a file open status and a program enabled status. So it's saying when file A is open and when we've programmed JHET SPG1 is enabled, then take the action. And you can see in the, if you go to the top right hand side of that, where that red box is, you can see a plus, a green plus. If you click that, that's where you add conditions. So you can, there's no limit on the number of conditions that you can add. So you could have, if you've got 20 files, for example, you could add one for each of those files, or if you've got a good naming convention, perhaps you could use a wildcarding. And going back to that customer who has all these bundles, he will have lots and lots of bundle enabled conditions added to his policy for all the particular bundles that he needs to be in a particular state. And then when we will evaluate all those conditions, and when they're all true, we will drive the action. And what typically they're going to do is they're going to set WLM health open to increase the health of the CICS region so it becomes eligible for accepting work. So I think I've probably said most of it on this slide here via the pictures. So the system rule requires, other system rules only require one conditions. This is multiple rules. And the difference here is for a compound condition, as soon as it's enabled, we will evaluate it at enable time to see whether all the conditions are satisfied. If not, we will wait, and when they do, we will fire the action. So if we move on, so I think that's probably the last, if I remember right, of the policy rules I'm going to talk about. So here's the set of system rules and task rules, the complete set. As I say, we've been doing a lot of work in version 5 and again in 6.1. They're proving to be quite popular, and now with the increased ability to easily scope them, we can see that they're going to get even more popular as a way of being able to let a CICS region help itself to avoid itself getting into trouble. So to go with those new set of policies, we have some. We also had some RFEs to do with reporting on policy usage. We already have policy statistics prior to this point via the statistics, the SMF 110 subtype 2, but you couldn't query stats online. So we had requirements in to be able to inquire using the SPI on policy and policy rules, and also an RFE to do with being able to extract statistics, use an extract to actually get the statistics for a particular policy rule. So the SPIs and the policy view editor work slightly differently in that the SPIs will show installed policy and policy rules, whether they're enabled, disabled, and that is regardless of scope. Whereas the policy view will, depending on what you clicked on the left-hand side of your Explorer screen, it will be scoped down to a particular region or a set of regions, a platform, etc. So the scoping works in Explorer as you'd expect for other views for resources. So in terms of the SPI here, we've got top left, you can see we've got inquire policy command, and you can inquire on particular policy or you can browse through them. We have inquire policy rules. So within a policy, you name a policy, and then you can browse through all the rules that make up a policy. And finally, at the bottom, extract statistics. So you can specify a res type of policy. You specify a res ID to name a particular policy. You then specify a policy rule, and a sub-res ID is the name of the rule within the policy, and that scopes it right down. So when you issue that extract command, you will get the set of statistics back for that particular policy rule. So that's the end of what I'm going to say on policy. A couple of things on application events. Now, events are slightly different from policies. Events are to do with being able to augment an application without necessarily changing it. Now, this has been around for a while. So, for example, you might have a program that processes an order, and it links to a program passing the order to the program that's going to process that order. And within the COM area, there might, for example, be a field that is the pound amount, how much this order is. And so you might want to take special action on, if the order is £500,000, that, oh, this is a big one, I want special processing. And so you can effectively augment application by driving an event adapter to take some action that when it detects that COM area field has a large number in it, for example. So we've had these for a number of releases. So one of the RFPs in here was someone noticed that the program name is not captured for system. Oh, I tell you what, I think I'm talking rubbish here. So this one, sorry, I will roll back and say this one is to do with an EP event for transaction abend system rule. Apologies, I thought I'd gone on to events. So this one is a last RFE that we had in the area of system rule, in that the transaction abend system rule, we pass a set of metadata for each of those rules, but it didn't contain the name of the program for the unhandled transaction abend. So that was fairly easy to fix. So in 6.1, the transaction abend system rule, the metadata that we pass to the event adapter that will contain the name of the unhandled event, or the program that unhandled event. This is the one I got ahead of myself. This one's to do with event capture. So as I mentioned, event capture is all to do with augmenting behavior of applications without actually changing the application. And we've added a new event capture point for put 64 container commands. So we had the ability for put container, but not put 64. So we've added that into 6.1. That's important because back in 5.6, we enhanced the CICS API that's used in Java applications, and we changed the underlying implementation of CICS to start using put 64 rather than put. And inadvertently, it meant that we no longer could support events for those Java applications because the event infrastructure didn't support put 64 container. So we've corrected that in 6.1. At the moment, we haven't back migrated it to 5.6. It's a possibility that could be done so if customers so wish, but as it stands, it's only in 6.1. So if we move off policies and EP, the next area I want to talk about is managing temporary storage capacity. So we've had an RFE into could we provide some capability to monitor when we're getting full as far as CICS is concerned. We already have capability for TS main, but we didn't have capability for AUX TS. We do now. So CICS will issue messages when, you can see them on the screen there, TS 1316, when 75% or more of AUX has been used up. And when it drops down back below 70%, we will issue the 1317 message. To go with that, we've added new statistics to report the current and peak percentage use of AUX, TS AUX. And so the idea, certainly with the messages, is you could use an existing message policy rule to drive some action if you're getting close to the limit on TS AUX. So this one's available in 6.1. We've actually backported that, but not the statistics. We can't change statistics mid-release. That causes all sorts of problems for our vendors. So the capability minus the statistics is available in 5.6 with the APAR you can see on the screen. Likewise, we've done the same for shared TS. We had some existing messages that reported the usage, but it was very hard to know whether you were actually increasing or decreasing. So we've actually put out some new messages for shared TS to report the percentage use of the entries and elements in the pool structure. And again, we've backported that to 5.6. And on this, I'm not going to go through this is on this slide. I'm just we're just summarizing the capability that you have for the various types of temporary storage. The bits in blue are the new bits. The bits in black on TS main, for example, are the existing capability. So we now report for both main, shared, and orcs how full you are, so you can take action. Another enhancement in the area of TS was a tweak to the expiry interval processing. So you can specify on a TS model an expiry interval, and we will go around cleaning up temporary storage. And the interval you can specify is either the larger of 1 minute or 10% of the smallest expiry interval. So we've had this for a couple of releases. We were getting some problems reported by cases, particularly in the area of shared TS, because if you have multiple regions all sharing TS, they would all try and clean up the shared TS at the same time, and you don't need them all to do it. You just need one region to do it. So we've enhanced that algorithm so that basically the algorithm will use a shared queue of its own called df shared, concatenated with the pool name, to hold some metadata, if you like, to report when the scan was last done. And so if you have multiple regions, they can look at that metadata and say, oh, this has already been done within the last minute, so I won't try again. The other thing we did was to correct an unplanned feature. Let's say we started using a TS model for the CICS MQ bridge to solve a customer problem, and we shipped the definition with a non-zero expiry interval, and that caused problems for some customers that all of a sudden they were getting more expiry interval scans than they had previously. So we corrected that so that we now change the expiry interval to be 0 until such time that you actually are using the bridge, and then we will make it non-zero. So for those customers who are not using the MQ bridge, they won't suffer that increase in TS scans. So you can see at the bottom of the screen here, the TS scanning enhancement is shipped backported via that APAR, and the correction to the MQ bridge is the second APAR on the screen there. So moving on again, so shared data tables. So we made some enhancements in 6.1 to do with the capacity for shared data tables. So if you're not aware, here's a sort of a one-page summary of how shared data tables work. So of course we have the ability for local files, and of course you have the ability to function ship requires file control request to an FOR, and the FOR will then access VSAM and access the KSDS, for example. With shared data tables, you effectively have a file owning region, and it has got the data held in a series of data spaces, and application owning regions can access that data using cross-memory services to access the in-core data without having to go out to vSAM to access the data. So we've had that for many, many years. So if you actually could look under the bonnet and see what's happening inside, the way it's implemented is by a series of 31-bit data spaces that are connected to the FOR that's got the data table, the shared data table. And you can, there can be up to 100 of these 31-bit data spaces, each 2 gig in size, so you can have up to 200 gig of data. Now, 98 of those data spaces, if you were using, the total amount, would hold your data, and there are 2 of them, DT001 and DT002, hold, if you like, metadata that the file control component needs to manage the data table. And data table, or DT001, contains what's called record descriptors and backout elements, and DT002 contains the index information in order to index into the data in the other data spaces. Now, the problem we had was one of capacity. We had a large US customer who was very, very heavily using shared data tables. And they were hitting the limit on the amount of metadata that we kept in those first 2 data spaces. Now, the limit depends on the key size of the vSAM records that are being held in the other data spaces. And at least 2 customers have hit this limit. So if I give you an example, if you have a 45-byte key, that limits you to about 36 million records before you run out of space in the control data set. It's slightly less constrained in terms of index capability. You can have up to about 100 million of those, but we did have customers hitting the limit on the first control data set or control data space. So they'd effectively had lots and lots of small records. They'd only filled about 4 or 5 data spaces worth of actual data, but they'd completely blown the limit in terms of the metadata that we're holding in those first 2 data spaces. So they couldn't actually add any more to the table, even though there was plenty of space left in those data-only data tables, data spaces. So the solution that we've done in 6.1 is to basically hold that metadata in CICS managed 64-bit storage. So we no longer have DT001 and DT002 containing metadata. They're now actually given over to the right-hand side, if you like. So you can now have up to 100 data spaces containing your actual data, and we'll manage the metadata ourselves within our own 64-bit storage. And I think I've said most of what's on that slide. We have a new SIP parameter called SDT memlimit, and we, in the same way as for TX AUX and shared TS, we will issue messages if you're approaching the limit of the shared data table's mem limit. So you set the overall amount of storage the CICS region can use in terms of 64-bit storage via the mem limit parameter. But we use 64-bit storage for a variety of purposes, be that TS main, be that container storage, and now for shared data tables. So SDT mem limit is, if you like, a subset of mem limit, and it allows you to constrict or constrain how much of your overall mem limit you want to allow for use for this shared data tables metadata. So moving on again, CICS DB2 enhancements, a couple of enhancements here. The first one is a solution to a very long-standing problem called the diamond deadlock problem. And I've tried to display that or show you that on the left-hand side of this slide there, with a series of CICS regions that, if you like, make up roughly a diamond shape. So the problem occurs when you're DPLing between CICS regions, and DPLing without sync on return. So we've got a long-running unit of work. And so, for example, if you have an application running in CICS 1 that DPLs non-sync on return to CICS 2, and that program in CICS 2 accesses DB2, the CICS DB2 attach will get a thread, usual stuff, and go off and get the data from DB2. So CICS 2 has got a thread, and in this diagram I've called that thread 1. So we've got some data. The program has returned back to CICS 1. Remember, it's non-sync on return, so we haven't sync pointed yet. And let's say you now DPL to a different CICS region to access a different program, which likewise goes off to DB2. Now, CICS 3 will have its own thread, and if CICS 3 tries to access the same data that CICS 2 has written or read or whatever, he's going to get locked out. And the reason, and it's called the diamond deadlock problem, is because DB2 doesn't know that thread 1 and thread 2 are actually part of the same unit of work. He just sees two threads, and he will stop thread 2 from accessing the data that thread 1's got. So that's the way that you can deadlock yourself. You can also deadlock yourself if one of those CICS regions was actually, for example, IMS, because IMS can talk to DB2 and then come back to CICS and so forth. So you can actually get the same deadlock, not only with just CICS systems, but with CICS and IMS. So how have we solved this problem? We've solved this problem by using what's called an XID, to pass an XID into DB2. Now, the XID is normally used for recovery purposes outside of the CICS environment, but we don't actually need the XID here for recovery. We've got all the recovery capability we need. We've had that for many years, but we're effectively using the XID as a token. And so if we can make sure that thread 1 and thread 2 pass the same XID to DB2, then that will allow DB2 to work out that, oh, this is two threads for the same guy. I'm going to allow them to read each other's data. And so that's how we avoid the diamond deadlock problem. So how do we, so it comes with a couple of drawbacks, if you like, in that we can, in this environment, if you're going to share threads, we cannot support held cursor support. So if you open a cursor for hold, normally, and you sync point, when you come back into the next unit of work, the cursor is still there and you can carry on where you left off. Well, unfortunately, if you're going to pass an XID involves what's called a sign-on to DB2, and a sign-on will kill the cursor, basically close the cursor. So we can't support held cursors with this capability. The other thing is, under the covers, we actually have to issue a call to RRS called an ATI query, and that adds some CPU overhead. So there is a performance overhead that comes with this, but we do have this capability if you so wish. Now, how do you turn this on? Well, we had some customers who required this capability out in the field, and so we've enabled it for 5.5 and 5.6 via a feature toggle called com.ibm.cics.db2.sharelocks. And if you set that feature toggle to true, it will turn on this capability, and we will pass XIDs to DB2. So for those releases, the feature toggle is, if you like, a bit like a SIP parameter. It's all or nothing. So it turns it on for all threads. It's take it or leave it. In 6.1, we can be a bit more granular, and we've removed the feature toggle in 6.1 and replaced it by a new share locks option on the DB2 entry. So in the same way that if you want protected threads, for example, you specify that via the protect num option on a DB2 entry. If you want this share locks capability, you turn it on via the share locks parameter on the DB2 entry. And you can define a DB2 entry with share locks in the standard set of ways: CEDAR, exec-kix create, CSDUP, etc. CMT and exec-kix inquire and set, and the Explorer will show you the value of share locks, whether it's shared or not shared. And we have some new statistics to go with that as well. The second enhancement in the area of CICS DB2 applications was the ability to pass what's called origin data to DB2. We had a particular customer who was wanting to audit security settings, and they were doing that by looking at the SMF data offline, but they needed the capability to do it online as well. So we already have the capability that you could do all this stuff offline by looking at the CICS 110 SMF records and the CICS DB2 101 records, and also the ZOS Connect SMF 26 records. But this particular customer, as I say, wanted to do that online, and so asked for the capability for passing what's called adapter data into DB2. So adapter data is set in the CICS SMF record when, for example, ZOS Connect connects into CICS, or, for example, an MQ bridge or a trigger monitor triggers an application. There will be what's called origin adapter data that we can pass to DB2. So if adapter data is present, we will detect that and pass it over to DB2, and it is available via DB2 special registers, the client's current client Apple name and the current client accounting special registers. So at the bottom of the screen, you can see that if you have connected in via ZOS Connect, the Apple name will be ZOS Connect, and the accounting string will be the ZOS Connect transaction tracking data. If it's an MQ triggered application, the Apple name will be IBM MQ, and the accounting string will be the queue names, the trigger queue name and the application queue name. So moving on again, as time is pressing on, I think I've got 12 minutes. So outbound HTTP and TLS improvements, a couple of tweaks here. We've had a couple of cases in where customers having problems with HTTP connections requiring lots of options requests. Excuse me, I'll just take a sip of water here, a minute. So for outbound HTTP requests, CICS didn't cache the information related to the remote HTTP server, so the IP address and the HTTP version. As a result of this enhancement, we do now, so that you won't need to do multiple options requests. We will cache the data. I think in the interest of time, I've said all that. So it's basically applies to web open requests that use a URI map and invoke service requests that use a URI map. We will cache the IP data so that we don't have to look it up again. Another enhancement in the area of URI maps, and this one was quite popular. So you'll see at the bottom of the screen, we've actually decided to backport this one all the way back to 5.4 via the API you can see. So the idea that you can have multiple client URI maps that point to the same host, port and path. This was previously not allowed. You can do that now. In order to distinguish between them, you will need to reference the URI map by its name. But it does allow, for example, CICS applications to have different specific security settings, different certificates, for example, depending on the service you are accessing. Another one, this is came as a result of a customer issue and response times to do with the excessive TLS handshakes. We had what's called contention on the LE heat latch, and so the CICS development guys talked to our LE colleagues in order to tune that to avoid contention on the heat latch. So I'm afraid I don't know, I'm not an expert on this one, so I don't know a great deal about it, but it solved the problem. We got the LE guys and girls to tell us the appropriate options to set there. There is more information in the IBM docs on that. Finally, in the area of TLS, we've also, as a result of a customer issue to do with running out of S8 TCBs, we've done some performance benchmarks, and we put some capability in to avoid the problem in the future. There was basically a slowdown, which basically caused all the S8 TCBs to be used up processing TLS handshakes, and so there wasn't any TCBs left for the applications to return their response information back to their caller. And so we've done some benchmarking, and we basically will now restrict the number of S8 TCBs that can be used for handshakes to 90% of the total max SSL TCBs. That leaves 10% for other uses and allows those applications to return the response to the client and not get locked up, as we saw in this particular customer scenario. So moving on again, a few API and SPI enhancements. The first one, when we first introduced channels and containers, and we added the channel parameter onto the start command, we didn't support all the options that you had with COM areas, in particular no check and protect. You couldn't specify if you're using a channel. We corrected that, and so they mean the same things they do with COM areas. So we now support that with channels. An easy one, or a requirement came in for the write operator commands to support a new option, cons name. The native MBS write operator allows you to specify the name of a console rather than using root codes. And so they asked, well, why isn't this capability available on CICS write operator? So we've added it. Assign invoking programs improved. Requirement came in for a customer who noticed that if you daisy chain from CICS1 to CICS2 to CICS3, when you go from 1 to 2, if you assign invoking program from region 2, it would tell you the name of the program in region 1. But if you went from 1 to 2 to 3, and it the assign invoking program in region 3, all it would do is tell you that the name of the mirror in region 2, and what you really wanted it to do was tell you the name of the original program in region 1. So no matter how many jumps you do, it will now return the name of the invoking program. And we backported that one to 5.5 and 5.6, as that one was quite a popular request as well. Another SPI command, again, as a result of an RFE, this is back to origin data. There was a customer, you can set your, users can set their own origin data that goes in the monitoring record. And you typically do that via an exit called the XAPA DMGR exit, which allows you to set user correlation origin data. Unfortunately for this particular customer, the exit was driven too early because they wanted to put some data in that they could only get when they'd looked at the header information coming in. And so they requested a different way other than the exit to be able to set their user correlation data. So we provided a set association user core data parameter. You must take account that there could be some correlation data already there. And so you must inquire first, add yours to it, and then set it back again. And you can, so this allowed the customer to use that command in a later exit that was driven later in the processing, an exec enabled exit, so they could issue the set association user core data and get their origin data correctly into the CICS 110 record. Moving on again, as I've got 5 minutes, inquire storage 64, we have an inquire storage parameter. So we now have an inquire storage 64, which tells you and gives you the same capabilities you have for non-64-bit storage. You can get a list of task storage that's associated with a particular task and find the length and the starting address of a particular piece of 64-bit storage. Inquire feature key. So these are the feature toggles. We've added a path parameter, file path parameter, to allow you to see the path name from where the ZFS file where CICS read the feature toggles from. And moving on again, finally, easier management of CICS. I told you I was going to be short on time with this one. So you're well aware that we've had short on storage capability from decades in terms of CICS managed storage. And in 5.6, we extended that so it managed ZOS storage. So this is storage outside of the DSAs, what used to be called OS core. And so we would monitor 24-bit and 31-bit storage. What we didn't have time to do in 5.6 was to actually notify, put some capability into notify other domains that might be interested if we're short on ZOS storage. So we've exploited that in 6.1 so that the security domains will free up ACEs, which come out of ZOS managed storage, and the region status domain, which is used for Sysplex optimized WLM. He uses that so that he can factor in a short on storage into the CPSM routing algorithm in the same way that it would do for CICS managed storage. It will do for ZOS managed storage. So if we're short on storage, he will route away and go and find someone else to run the work. Customer had a problem with the logger, unusually, because the logger is normally pretty rock solid. They had a particular problem in that they had a volume problem, which caused the logger to have a problem. The logger recovered, but unfortunately, they had to manually go and reset all their user journals. They were heavily into user journaling, and they had to actually go and manually reset or reopen all their user journals. Well, we've put some capability in so that CICS will recover in that situation, so they don't have to go and manually re-enable their journals. Some improved messages for TCP/IP initialization. There's basically a race goes on if you after a ZOS IPL. There's a race that goes on who comes up first, whether it's CICS or TCP/IP stack. And if CICS comes up first and tries to talk to the stack and the stack's not up, excuse me, you got some really weird message with an even weirder return code. And it took quite a while to actually diagnose that what it actually was we tried to talk to the stack too early. And so we put some more meaningful messages out so that with some indication that you need to retry. Daisy chaining of non-terminal starts. This is a customer who noticed there was an inconsistency in our daisy chaining of non-terminal starts. They had a capability where they could daisy chain when they were using APPC, but it didn't work for MRO IPIC links. So we've corrected that. It was kind of working a bit by luck for APPC, but they got away with it. And so we put some new capability in. So you explicitly have to request via your, this is a customer who had their own routing program. So you actually have to turn on this capability via a new field in the COM area, but for the distributed routing program. And if you do that, you will now get consistent behavior across MRO, IPIC, and APPC. And finally, I think this is a feature toggle to allow you to adjust the behavior of CPSM Sysplex optimized WLM, so that if you've got a extremely high frequency, you've got a spike of work, you might want to mitigate that by letting it spread it out, even if it's not a local region, to get over that spike. And so we've given you a feature toggle to allow you to choose which way to go, whether you want to stick with the local region and let it endure the spike, or whether you want to spread that work out across other regions, which might not necessarily be local, they might be remote regions. And finally, the CICS SVC. We basically shipped the 6.1 CICS SVC and IRP early via maintenance on 5.4, 5.5, and 5.6. They're new modules called DFH NCSVC and NIRP. So if you apply the maintenance and don't do anything else, nothing happens. But if you want to get hold of the 6.1 functions early in order to fit in with, for example, your IPL schedule, you could, and you're, for example, running on 5.6, with this maintenance, if you follow the documentation, we will show you how to rename those modules to the required names, and then you can IPL, and now you've got 6.1 CSVC and IRP in early, and so you can take advantage of your IPL window, and then a few months down the line, when you do get 6.1, you're off and running straight away. You don't have to wait for the next IPL to get IRP and CSVC in. And yeah, I've said all that. And finally, very finally, I'm sure you're all aware, we have a new process for raising RFEs. They're now called ideas. So you can either raise it via ideas.ibm.com, which is what's called the unified portal, which is you can raise a requirement on any IBM product. Or top right, this one's a little more Z specific, and CICS is in there as well. So either of those places is where you go to raise RFEs, which are now called ideas. And with that, I'm two minutes over. I apologize. I thought I was going to be very tight on time. I guess I'm probably don't have time for questions. So at this point, I'm going to hand back to Rob. Thank
you very much, John. Lots of content there, and a great job fitting it all into the time, or just about. Yeah, we got one question from Sharon, and I think Steve Foley was busy typing an answer, and I'm not sure, because I've got a different screen up now, whether the answer was okay. I just see a thank you from Sharon. So I'll just read the question out. It's probably the best bet. When using XID, do both threads have to complete successfully in order for CICS to sync point? And conversely, if one part fails somehow, are both parts rolled back, or whatever is defined for that TRAN?
Yeah, basically the recovery capability isn't affected. CICS will do what it would always do, so it will sync point them both, or it will roll back them both. Yeah, the XID is just to tell DB2 that these are part of the same unit of work.
Yeah. So
don't look them out.
Thank you, John. Jenny's posted the feedback link for everyone, which we'll do after every session. 50 attendees on average during our time. So thank you, everyone. Our idea with these virtual sessions is to reach more people. But I'm going to wrap up now. If you want to do the next session, we're back on in just a bit for 4B, and it should be the same link and number. I think the website might be struggling with performance. So if you stick with your credentials you've got now, you can get into the other CICS sessions. Best of luck, everyone. And thank you so much, John, for attending. We really appreciate your support. Thanks guys.
Rob. Thanks
Cheers.
very much. Thanks.
So there is a question about the recording will be available. Yes, it will be.
Yes. All the recordings will be available, but you do have to be a GSE UK member to access the website to look at the recordings. So as we've opened up these sessions to everyone because we want to try and build the community, but the recordings usage is restricted to GSE UK members. If you need a company to join, feel free to contact me offline and I can hook you up. Okay. If there's nothing else, I'll close the session. Thank you so much, everyone.